So I'm going to go to the Windows tab up here and go down to Function Legend. And this is described step by step on that slide. And so this function legend can be used to filter out different functions that you don't want to look at, so you can clean up what you're looking at. And so I'm going to hide everything except those things that match phase_MD, which is the label I gave to my phase. And I'll hit apply. And when I do that, then you see that now it's only showing the phase MD. And I can pull that up and look at it. But it's just one block, right? So if you want to see everything in the phase, then you right-click on this line and you say Open Profile for this phase. So now it brings you up. Now I've gotten rid of all that startup time, and these are just the functions I was interested in that are in the MD loop. So this is a really cool feature. I think it's really it's something that can really help you to isolate performance issues in areas that that are important. And you can define I/O, and you can just do a lot with that. So so now if I click on this, this is what I showed you in the slide. I can get at this one main function and without interference from all the other stuff that doesn't really matter in the long run. But what I'm going to show you here is that here is the ParaProf manager. So you want to keep an eye on this thing, and I've loaded one. This is called the trial. Okay, it's got a really long name, but in the end it will point to the file that I loaded, this .ppk file. Okay, and so I stripped away from this one everything that was not in my phase, and so now I'm going to right-click on that trial in the ParaProf manager and say add everything that's showing to the mean comparison window. So it'll create this window with all these functions listed, but notice that they're only functions that are within phase MD. So you see this phase MD before all of these functions, because that means they're all within that phase. This is the program. So this is really nice because this gives you the total execution time of the phase that you're interested in. So this is the entire phase, and then it breaks it down. In the normal view, you just see the function output time, but you don't see the time for your total program. So this gives you the time for the total phase, which is the time we're interested in. So if you run those exercises with lamps or with unres, I checked this on lamps, I'm sure, and so I think if the instrumentation doesn't perturb things very much, this is a nice check, because lamps times, part of the output of lamps is just the MD loop. And also I think I showed you in unres how to get just the MD loop time. And so that time should theoretically exactly match this phase MD time that I get from tau. And I checked that on the lamps example on Queen Bee, and the time was literally exact down to the third decimal place on the loop output time that lamps reported and the phase MD time reported by tau. So that makes you feel really good. That means that something's working there. And you should check that. If you do a phase profile, you should try to find checks like that, sanity checks, to make sure that the timings that you're getting are reasonable and that you haven't messed something up in that instrumentation. So now this is just for this light blue now shows the run on 2 cores. So now I want to get a comparison across all these functions going from 2 cores to up to 32 cores for each one of these functions, and look at where the bottlenecks are that develop within that particular phase of interest. And so to do that, then I want to go back to this ParaProf manager. I've got limited screen real estate to deal with, but I'm keeping this ParaProf manager in my upper left-hand corner so I can get back to it. And so now you click on this default experiment, and then right-click on it and click Add Trial. So that will allow you to add another ParaProf packed profile, which is what somehow PPK represents, ParaProf packed I think is what that means. So this is the PPK file in any case. And you click on Select Files, and I'm in this directory with these different tau instrumentation runs from 2 to 32 cores. And so now I'll take the next one, which was on 4 cores, and click OK. And now the whole thing comes up. But again, this one's contaminated with this long setup time. But here's my phase in this one too. And so now I'm going to, so I can tell it to open the profile for just that phase right away. That's all I have to do if I just want to look at it like this. But if I want to add it to the comparison window, then I need to again go to this window, to the function legend, filter, advanced filtering, and type in phase_MD and hit apply. And then I can go back to this Paraprof manager, click on the trial, right click on it, and hit add mean to comparison window. And so then this comparison window comes up again. And so now I'm getting this nice comparison with increasing processor count for all of these functions. I'm only looking at the functions that I'm interested in within my defined phase. And so I can repeat this process for all these files and get that comparison. So going back to the manager, clicking on default experiment, add trial, select file. I'll skip to 16. So I double click on that one, hit OK. It adds it in. I've got to go back here. So it's a little bit of a process if you want to do that comparison, but it makes a nice demonstration of what's going on. You go to the function legend, filter out just the phase MD, and I think it would be a nice feature if they could streamline this a little bit, but so I filter out everything. So now you can kill these windows. Go to the Paraprof manager and right click on that trial and add that one to the mean comparison window. So now I've got 2 cores, 4 cores, and now 16 cores lined up. And you can see how each of these functions is scaling and contributing to the overall runtime. So any MPI calls that are called within that phase are there. And so these are just the major functions of interest there. So are there any questions on working with a phase profile or any other questions that come up? Were the build problems resolved for the example? Okay, so not hearing any cries for help, then I'll look at, there's one last, well, there's a couple of things. There's, I mentioned showing a trace, or getting the trace information. I showed you how to specify only the functions you want by having an include list in the selective instrumentation file. And so if you do a run with just a few functions included, then you can get a nice trace. And on that cheat sheet that I showed you in the slides, it shows you a series of commands to translate what the output from that trace to a format that tau can look at. And so that is, if you want to look at that, then that is here in the lamps, on that examples page under lamps. Then you have this trace file here, which is it's called slog2. And this is, even though I was really careful with doing a very short run, it's over 32 cores. But you can you can see it, this one's 41 megabytes. If I ran, and I only ran that for 20 steps, if I ran it for 1,000 steps, then it gave me a 1.5 gigabyte file. So that's just an example of how those things can blow up. But if I go here to lamps and Queen Bee, I've already got this trace. So you can see there's tons of information here. All those lines are the actual, every single MPI communication that happened in your program. But as I mentioned, you can really reduce this to, say, just the main parts you want to look at. You can look at it piece by piece. So if you go over here, the V stands for visibility, and this stands for searchability. So if you want to take off some of these things that you don't need, you can right-click on that, and you can disable everything. And then you have to come back here and hit this refresh to redraw the screen. So now there's nothing showing. And so now I can just go back in and add those things that I'm particularly interested in seeing. There we go. So I can look at the name. So I know that this is a major function, and so I'm going to click on a few of these. And then you refresh the view, and there you can see where those things are. And then if you left click and drag, then it will zoom in on these different functions. And see, if you right click, then it brings up the name of the function, and you can see the time resolved view of these things. And you can see there's a lot going on. You have to really zoom in to see everything that's going on here. So here is the main computational function, and you can see how much time each of these takes at each iteration in your code. So just a little taste of what you can look at when you look at these instrumentation files, or these trace files. Okay. Is there anything that anyone would like to see in particular before I leave this this particular part of demonstrating some of how to run a job with Tau and how to go through some of the analysis modes?
Phil, are lines drawn for the MPI calls?
What's that?
Are lines? Can you look at an MPI call? Do you see lines?
Right. Yeah.
Between,
So.
the source?
So the right. So some of these. Let's see. Where are they? So let's look at. Let's show MPI send. Okay, so this shows all the MPI send function calls, but to see the lines, then I think it's one of these here, these message lines. So let's go ahead.
Oh, okay.
Let's go ahead and add these in and see what happens. Okay, so there's all the lines, and so